Hello, my amazing students. This is Mrs. A, and we are doing 9.5, which is all about adding, subtracting, and multiplying radicals. So remember, in class I talked about like terms. You've been doing like terms since you were in elementary school. First, you had to get like denominators, and then later on in algebra, you had to get like variable parts. And now we're adding to the mix with like radicals, okay? So the first problem they give us is one that doesn't have any radicals at all. It's just got variables, but they're showing you what like variable parts are. So 9x plus 2x. And remember, the reason they can do this is because the x can be factored out. In the PowerPoint, they factored the x out to the back. It really doesn't matter. And then if we factor the x out, then we've got a 9 plus 2. And you can see that if we distributed back, we would end up going back there again. And 9 plus 2 is 11, so we get 11x. Now, this little step is not necessary, but it is explanatory, okay, to let you know what is the reason behind us being able to add those together. So then down here, we're going to have the 9 plus 2, since they're both square root of 5, so we can, just like we did here, pull the square root of 5 out, add the two coefficients together, and get 11 square root of 5. On the next one, again, we have like square roots, so we could pull the square root out to the back and end up with 3 minus 4 inside. 3 minus 4 is negative 1, so negative square root of 7 would be the answer. Now we get to the fun stuff. These are not alike, but if we simplified this one, would it have a square root of 2? So let's try. We're going to break this up into a perfect 25 and a 2 left over. The square root of 25 is 5, square root of 2. So now we have 5 square root of 2 plus 4 square root of 2. Since they are both now square root of 2's, we end up with 9 square root of 2 when we add them together. So now we get to party some more on this one. We've got a 5. We break up the 27 into a square root of 9, a square root of 3, plus the square root of 16, a square root of 3, minus 7. Okay, see how much easier it is if you know your multiplication facts. And of course, I've done this a lot longer than you have, so a lot of these just come very easily to me. 5 take away 7 is negative 2, so we'll have a negative 2, and then this one becomes a 3 when we pull it out of the radical. This one becomes a 4 when we pull it out of the radical. And since they have the same radical parts, we get 3 plus 4 is 7, square root of 3. Okay, down here, again, we're looking, can we simplify the cubic root of 16 so that it turns into a cubic root of 2? So this one we can't do anything with, but we'll just write it down. Cubic root of 2 minus the cubic root of 8 cubic root of 2. And the cubic root of 8 is 2. So we wind up with 6 square root of 2 minus 2 square root of, excuse me, this is cubic root. This is cubic root of 2. And now, last step is I at least mentally factor out that cubic root of 2, and then I have 6 minus 2 is 4 cubic root of 2. Look at that hodgepodge. Okay, now let's examine this. No matter how I simplify things, I cannot get a cubed root to match a square root. So my best is going to be to add those two together and add those two together. If I can't, then there won't be anything I can do because the square roots cannot be added to the cubic roots. So on this one, we've got 5 square root of 3. And I'm going to just bring this one, since it's a square root, I'm going to bring it over here to be with this one. But I'm going to also factor it into perfect and leftovers. And then I'm going to do the same thing, -4 cubic root of 3, but that's already simplified. And then plus 2 cubic root of 27 is perfect. And then the leftover cubic root of 3. I'll squeeze it in there. Okay, I'll squeeze it real tight. So now we've got, this one becomes a 3. And since they're both square roots of 3, I can separate these two, square root of 3. And then I've got a minus, let me just write this a little bigger, -4 cubic root of 3. Notice that this is 2 times the cubic root of 27, and the cubic root of 27 is 3. So 2 times 3 is 6 cubic root of 3. So now since I have cubic root of 3, cubic root of 3, I'm going to get, for -4 minus 6 is 2 cubic root of 3. And you're done with your problem. All right, now looking at this one, this is already simplified and this is simplified. This is simplified and this is simplified. So I'm going to join these two together and I'm going to join these two together because they are already simplified radicals. So if I take the 4 square root of xy and the 1, remember that's understood to be a 1 right there, then I end up with a 5 square root of xy. And then I take the -3 square root of x and the +2 square root of x is a negative square root of x, or -1 square root of x. That's all I can do to that one. All right, I want to correct this board. We did this one correctly here when we put these two together. And then these over here were cubic roots, and I got that one correct. But it is very late and I am very tired. I forgot to join this pair with this pair. So this one was not the final answer. This is a square root. That is a cubic root. I cannot do anything to add them together. Therefore, that is the answer to that one. Sorry about that. Okay, so now as we continue to add and subtract radical expressions, we have 2 unlike expressions, but will this one simplify to be similar or like with that one? So we're going to break this one up. 7 square root of w squared, square root of a leftover w, minus 3w square root of w. Now this square root of w squared is just w, so we get 7w square root of w minus 3w squared of w, and they are like terms. They both have a w, they both have a square root of w, and so 7 minus 3 is 4w square root of w, and that would be our final answer there. Now this one, we have a mess that does not look like at all, and let's see. All right, so we're going to break this one up. 5 square root, there is a 4 in 20, so we're going to break out the 4, leave the 5 in the leftover. A is going to have to go in the leftover. B to the 5th, we'll put a B to the 4th here and a leftover B here. And then we come over to the second one and we break it up into the 5 will be a leftover, the A will be a leftover, the B cubed has a B squared, and then another B would be in the leftovers. So now when I finish simplifying this one, I'm going to wind up with 5 times 2b squared square root of 5ab plus 6b times b, because this one's going to come out as a b, and then tack on the 5ab. So we have the 5ab is like a b squared and a b squared, so we get to add these together. So this is a 5 times 2, or a 10b squared square root of 5ab plus 6b squared square root of 5ab. And then, since they're all like terms, b squared, square root of 5ab, square root of 5ab, we can add the 10 and the 6 together to get 16b squared square root of 5ab. And there is our answer. Okay, well, this one certainly looks a mess. We have to see if it cleans up. So we got cubic roots this time. So we got cubic root, and a cubic root is 8, perfect, and leftover 3. M cubed is already perfect, and n squared has to go in the leftover, because we're talking about cubics now, cubic roots. So minus 2m, and then in 81, a perfect cube is 27 with a leftover 3, and an n squared will have to go over here in the leftover pile. So now, when we pull this out, it becomes a 2m. Multiplied by the 6 is a 12m. And then a cubic root of 3n squared. I forgot my cubic root here. I forgot my cubic root there. I forgot my cubic root there. Like I said, it's very late here. All right, so minus 2n. Now this is going to become a cubic root of 27 is 3. So that's going to be minus 6m, because I'm multiplying. And then the cubic root of 3n squared. So they both have an m, and they both have a cubic root of 3n squared. So we can indeed add them together, and we will get 12 minus 6, or 6m cubic root of 3n squared. Final answer. Okay, so now we're moving into the multiplication. We've done addition and subtraction. Now we're moving into multiplication, and they're going to start us out with a constant in front of a binomial or a distribution problem. So that's just going to be a 5t minus 20, and this one's going to be a 4 square root of 3 plus 28. Not much to those. Okay, so on this one, we've got a square root of 2 being distributed. Now we look carefully, because this is a square root, square root, square root. As long as they have the same index, then we can multiply them together. So I'm going to distribute each one of these through. Remember, there's an understood 1 over here. So 1 times 5 is 5. Square root of 6. What's in the radical, we can multiply with something else that's in the radical. And what's outside the radical, we can multiply with something outside the radical. So now again, this one over here is an understood 1, because there was nothing there. So I'm going to distribute this through. That was a negative though, so it's a negative 1, or just a negative. And then when I multiply the insides, it's the square root of 54. So I have a negative square root of 54. So now, oh, excuse me, I was looking up there. I see what I did. This is a different problem. I'm going to put this right here and erase it from right here. This is a different problem. All right, so now if I look at square root of 54, 6 is a factor of 64, and I can split this one up into a square root of 9, square root of 6. So I'm going to take my 54, since I'm running out of room, and I'm going to split up the square root of 54 into the square root of 9 and the square root of 6. And then I've got 3 here, so I wind up with 5, take away 3, which is 2 square root of 6. And down here is another problem. I've got square root and square root, so I can multiply. I'm going to distribute, and get, this one is outside, so 21 square root of r minus 35 square root of r squared. Well, we know the square root of r squared is going to become just an r. So these are not like terms, and we would have to leave them separately. So my final answer would be 21 square root of r minus 35 r. Okay? I'll be back with more in a minute. All right, so with more multiplication, we are now foiling two binomials, and this one is an example again of just foiling because you have no radicals in here, but here we do. And remember, when we FOIL, we're going to do the first, and k times k is k squared. And then the outside is going to be negative 3 times k, or negative 3k. The inside is going to be a positive 6k when I multiply together. And the last is a negative 18. And we go back and we look and we say, yep, the inside term and the outside term will add together to give me k squared plus 3k minus 18. And there we have that one. Now we're foiling, but we have a radical. So we're going to have the first term is 6. The inside is 2 square root of 7. The outside is negative 3 square root of 7. And the two last multiplied together will give me negative 7. Now, notice that my 6 and my 7 and my my square root of 7's will go together. So 6 minus 7 is negative 1. And 2 minus 3 is negative 1 square root of 7. So we should have that as our answer there. On the next one, we're foiling, and we're going to have our first will give us 15 because the square root of 15 squared is 15. Our outside will be negative 3 square root of 15. Our inside will be negative 4 square root of 15. And our last would be positive 12. The 12 and the 15 will combine to give me a 28. And the negative 3 square root of 15 and the negative 4 square root of 15 will combine to give me a negative 7 square root of 15. All right, so now we're going to FOIL again. We've got a 3 square root of y and a square root of y. When we multiply them together, we get a 3y. Okay, our outside, remember outside goes with outside, so negative 6. Inside goes with inside, square root of 5xy. Okay, on the inside, I've got a negative 1 and a positive 1, so it's going to be negative square root of 5xy. And then lastly, the last ones. Okay, so we got a square root of 5x, a square root of 5x. Multiply them together, it's squaring them. So we're going to wind up with the negative times the negative is a positive 2. So 2 times 5x will be 10x because the 5x will come out. And then I look and I say, well, I got a 3y on the front. I got a 10x on the back. But I do have these two terms that will go together. Okay, so I got a negative 6 and a negative 1, and they're both the same radical part. So I'm just going to make this -6 into a -7. Erase this one off of there, because they both combine to give me -7 square root of 5x, and then plus 10x over here at the end. Don't forget this guy. All right, so on this one, I just erased it, I guess. So it was a 6t plus 5 squared. Okay, so on this one, we don't have a radical either. But they're putting it here as a reminder of what happens when we square. Remember, a plus b quantity squared winds up equaling a squared plus the product ab doubled plus b squared. Okay, so this formula we should know, and we're applying it here. So this squared is going to be first term squared, or 36t squared. The product of those two doubled, so that's a 30t doubled is a 60t. And the last term squared is a 25. And none of those will combine or simplify at all. So here we're going to do the same thing with a radical. And we're going to have the first term squared, which is 1. The product, negative square root of 3, doubled, which would be -2 square root of 3. And the last term squared, which is plus 3. Cat, get out of the garbage. Cat's going to try to turn over my garbage there. Okay, so -2 square root of 3 and add a 3. So now the 1 and the 3 will go together to give me a 4 minus 2 square root of 3. And we have our answer there. Okay, so we're going to
empty the garbage.
Do the same thing. Thank you. So we're going to do the same thing here. The first term squared is just x. The product, remember, what's inside the radical can multiply with what's inside the radical. So that's going to be a negative square root of 7x. Okay, and that's going to be doubled. So that product doubled. And then the last is plus, that one squared is 7. So there's nothing I can do to change that. That's as simple as I can get it. Okay, so the first term squared, the product of the two terms doubled, the last one squared. So that was a binomial squared. I'm not sure if I said that was a FOIL. That's not a FOIL. That's a binomial squared, which is what we're working on. This one is conjugates. And conjugates are when we have the same terms but opposite signs in between them. So when we FOIL it, we get the first is n squared, the outside is -6n, the inside is +6n, and the last is -36. The inside and the outside will cancel out, so we end up with n squared minus 36. And then we have a couple more conjugates here. Square root of 13 plus 4, square root of 13 minus 4. When we FOIL this, we're going to get 13. And then the inside will be 4 square root of 13. And the outside will be -4 square root of 13. So again, those will cancel. And my last will be -16. So I wind up with 13, take away 16 is a -3. This one right here is going to wind up being 11 times 11, or 121. The inside and the outside will cancel because they're conjugates, minus k. And we have one more problem to do on that set. So I'm just going to get a board and do the problem. instead of turning off my video. So it's 3 square root of w minus 4 square root of x times 3 square root of w plus 4 square root of x. So this is conjugates again. Same terms, opposite signs. So now this, when I multiply these together, I'm going to get 9w. The inside and the outside should always cancel because they are conjugates. And then the last term squared would be minus 16x. And I think that we are done with 9.5. And this is Mrs. A, and may God bless your day. When I went over the answers, I found another boo-boo. 15 and 12 is not 28. It is 27. Other than that, I found no more mistakes, and I'm done.